Hi, welcome back to Mr. Stewart's Lessons, and I'm here with a better way to not walk through walls. Right now, I have created a maze lesson where the mouse has walls and he can't walk through them. You can download that right now at Mr. Stewart's Lessons if you don't have it. What happens right now is that the mouse indeed can't walk through the walls. They get in his way, which is what we want. But what happens is if he ends up with the wall partially in his butt, which I'm trying to get to happen right now, he gets stuck and then he can't move. And that's not what we want. It's not, and I'm going to come up with a better way to not walk through walls. And this is what we're going to do is we're actually going to look, or I'm going to make a method to look and see if a wall is in front of us. So what I'm going to do right now is, first of all, I'm going to get rid of the part that I don't want anymore, and that's the check obstacle method. You see what happens with the check obstacle method. Basically, if I set rotation to whatever direction I'm going, I move, and then I run the check obstacle method, I see that if I'm intersecting a wall, that is, if I'm touching it, and if I am, then I move backwards. But it happens so fast that you don't know that that's what's happening. But it's not perfect because sometimes I get stuck even when there's not a wall in front of me. So I'm going to get rid of that, and I'm going to get rid of all references to the check obstacle method. So I highlighted the check obstacle method, and I'm highlighting all the references to the check obstacle method, and I'm deleting it. That's what you should do as well if you have this lesson. So, and you will be back to, and so all that happens right now is you have it sets if Greenfoot is key down right, I set rotation to 0, move 5. If Greenfoot is key down, I set rotation to 90 and move 5, and so on. And there's no check obstacle method down here. So that's what you're going to want if you if you're following along here. And you'll notice that what happens now if I compile it and run it, that I'll just be able to walk right through walls, which obviously also isn't what we want. What we really want to do is get to this point, and I want to look and see if a wall is in front of me, and I only want to be able to move if a wall is not in front of me. So, how can I look to see if a wall is in front of me? You might be thinking, get one object at offset. Get one object at offset looks in a certain direction from you and sees if there's something there. And the way the offset works, it works by the x and y coordinates, right? Y being up and down, x being left and right. If I get an object at offset 0, -10, x equals 0, y equals -10, I'll be in the same place on the x, and I'll be 10 up on the y, so I'd be looking right here, right? If I get an object at offset 0, 10, I'd be looking down here below me. If I get an object at offset 10, 0, I'm looking right here, and if I'm getting an object at offset -10, 0, I'm looking right here. Now, you might be able to see what the problem is here. Since I'm facing left, right now, I'd want to get an object at offset 10, 0. But now I'm turning around, I want to get an object at -10, 0. And if I'm facing down, I want to get an object at 0, 10. And if I'm facing up, I want to get an object at offset 0, -10. So how are we going to do that? So I'm going to come up with a method that's going to quickly, and it's going to, I'm going to create the same, you follow the same method of get one object, and I'm going to call it get one object in front. So I'm going to open up the mouse class, and I'm going to create a method called private object actor get one object in front. And so just to now you may be asking, why is it private? Well, a lot of things that I've been doing as public should be private. It's private because only the mouse is going to use it. Nobody else is going to use it or call it. And really most of your methods that we're calling public should really be private because only the mouse is going to be using this. Why actor? Because it's going to return an actor. It's going to turn the actor that's in front of you. And so what I'm going to do, right, what I want to do is I want to look in front of me. So how do I look in front of me? The way we're going to do it is we're going to do some fancy math. We're going to do some trigonometry. And it's okay if you haven't learned trigonometry, because trigonometry is hard. And if you have, that's great too. All we need to know right now is something called the sine and the cosine. And I'm not going to go into detail, but in short, if I have a direction, which is going to be an angle, right? In this case, I'm looking up. So if I'm looking up, my angle is if I'm looking up, my angle is going to be 270. If I'm looking right, it's 0, 90, 180, 270. Right? That's going to take my angle, right? And what I'm going to do is I'm going to look for some. So if I take an angle, if I use the cosine function, which is a trigonometric function, it's going to turn that angle into an x coordinate. And what's going to happen is if I use cosine, if I'm facing right, it's going to be turning it into a positive number. If I'm facing left, it's going to be turning it into a negative number. If I'm facing up or down, it's going to turn it into a 0 number. And the sine is going to turn the number into the angle into a y coordinate. So I'm facing up, it's going to turn it into a negative number. If I'm facing right, it's going to turn it into a positive number. If I'm facing, it's going to turn it into a 0 number, or left is a 0 number. If I'm facing down, it's going to turn it into a positive number. By the way, this get object in front is going to work even if you have an object that goes at a different angle than, say, it'll work even if it's going like this, right? So I'm trying to make this into something you can use for lots of different purposes. So what we're going to do, first thing we're going to do, we have our angle. Right. First thing I want to do is I want to know how big my image is. I need to know how big my image is because I need to I need to know how big my image is because I need to know how far to look. Right. If I need to know how far to look in front of me, it's going to be half the size of my image. So I'm going to create an image, right? First thing I'm going to do is I'm going to get my image. So I'll make an image variable. This is just getting my image so I can do something with it. And the next thing I need to know is how far it is to the front of my image, which is basically half the size of my mouse image, right? So it's going to be from here to there is half the size of my image. And so what I'm going to do is I'm going to say int distance to front equals my image get width. So basically half the width of my image is to the front of the image. Okay, so now next thing I'm going to do, missing return statement because we haven't returned anything yet, but we will. The next thing I'm going to do is I'm going to create what the offsets are. So I'm going to have an x offset. The x offset is going to tell me, how far I'm looking to the left or right. The y offset is going to tell me how far I'm looking up or down. And so I'm going to create int x offset equals. And I'm going to build this up slowly because it will look very complicated when the whole thing's finished, but it's not really as complicated as it looks. Basically, all I'm doing is I'm taking the cosine of my whatever my angle is. So let's start with my angle. First, I need to get my angle, which is using the get rotation method. Next, I need to take the cosine of it. The cosine is in a module which is automatically imported called math. And math is any kind of fancy math you want to do. You want to take square root, or you want to take raise something to a certain power. You want to do anything fancy, find a minimum or a maximum of between two numbers. It's all in the math module. So I'm going to type math with a capital M, and I'm going to do control space, and you'll notice I have a bunch of different options, choices here, and the one I'm looking for is cosine, C-O-S. And my get rotation is actually going to go inside the COS, math.cos. Okay. So now we're taking the cosine of the rotation, and it seems like that's all we should have to do, but it gets more complicated than that. The main reason is your rotation is a number of degrees, 90, 360, 180, 270, or 0. The cosine function in Java does not work with degrees. It works with a different measure of angles called radians. I'm not going to explain what radians are right now because that's a whole math lesson by itself. I'm just going to tell you that it's a different way of measuring angles. And so what we have to do is we have to convert the rotation from degrees to radians. And so and that is another math method. So I'm going to say math dot, and there's another method called 2 radians, and it turns something from radians to degrees. And the get rotation should be in the parentheses inside the 2 radians. Now, we have to be careful to count our parentheses when I'm doing all these things with parentheses. The best way to tell is when you look at the last parentheses, you should see that this parentheses should be highlighted. That tells me that this parentheses here closes this parentheses. We have to really make sure and count them all, because we're going to need one more set of parentheses here, because we actually need to but first what we need to do is when we get the cosine, it's going to give us a number between 0 and 1, because that's the only thing a cosine can come out as, is something as a number between 0 and 1. And we need to multiply that by how far we need to look, which is the distance to the front of the object. So I'm going to take the distance to front, I'm going to copy it, and I'm going to paste it right here. I'm going to put a star, which means multiply. So we're going to get the rotation, we're going to convert it to radians, we're going to take the cosine, we're going to multiply it by the distance to front. And it seems that should do it, but it doesn't, because there's one more thing we need to do, because x offset is an integer. An integer is a positive or negative whole number, but the cosine is going to come out as a decimal, and will almost certainly still be a decimal even after I multiply it by the distance to the front. What we really want to do is we want to round it up, and so we need one more math method, which is math. The thing for rounding something up is going to be math.ceil. Ceil is short for ceiling, as in going up, right? And I'm going to do an open parentheses here, and I'm going to come all the way over here and add another closed parentheses, and you'll notice this parentheses closes this one here, which is what we want. And we should be done now, but we're not. There's one more thing we have to do, which is we have to make sure that our answer comes out as an integer. Even though at this point it should be a whole number, to Java it's still a different kind of number. It's going to come out as a float, or possibly a double. Either way, I think it's going to be a float, but either way it's not an integer, and it's going to give me a complaint about something called loss of precision, which means you might lose some information. So we're just going to force it to be an integer, and the way we do that is by typing it, and that's by putting int in parentheses in front of it, and that's basically saying take this information and force it to be an integer whether it likes it or not. So what happens, we get the rotation, we convert it to radians, we take the cosine of that, we multiply that by the distance to the front to see how far we need to look. Then we do the math.ceil, round it up, and finally we convert it into an integer. And now we're going to do the same thing for the y, but since we're doing the exact same thing except for one thing, I'm just going to copy and paste the whole thing. So I'm going to highlight the whole line. I'm going to press copy, then I'll click down here and I'll click paste. And I'm going to make this y offset instead of x offset. And the only other thing I need to change is I need to, instead of taking the cosine, I need to take the sine. And so now, and now what we need to do is we need to actually return the thing that we find. So to return the object that I found in front of me, I have to know what class it is. And so I need an argument. I need basically the object, the get one object in front, just like if I say get one object at offset or get one intersecting object, it's going to want to know what class we're looking for, and so I'm going to ask for a class to be looking for, and so I'm going to say class C, and so this is an argument. It's going to expect a class like wall.class. For example, C is the name of the class that we're looking for, right? Class is saying what kind of thing it is that we're getting. And so what I'm going to do is we're returning an actor, right? So an actor is the thing that's being returned, right? So I'm going to say return. So I'm going to do open a parentheses, and then I'm going to do get one object at offset. And I'm going to the x offset we created here, so I'm going to copy that and paste it. And the y offset we created, so I'm going to copy that and paste it. And the class, well, in this case we're looking for a wall, right? But it could be anything. So C is going to be the class that I'm looking for, right? So this C is going to be put into the get one object at offset. I need to close that parentheses and do a semicolon. Now my method works. Now all I have to do is call it every time to see if the thing's in front of me. So I'm going to say if, and I made this on purpose so it'll work just like get one object at offset or get one intersecting object or anything else. It'll be like if I'm going to say if get one object in front, and we're looking for wall.class equals null. That is, there's no wall in front of us. Move 5. And this is it. You might be thinking, where's your curly brackets? And in fact, since only one thing is happening in response to this if statement, that is, we're only moving 5, I don't even need my curly brackets here. So I'm going to make it without the curly brackets. I'm just going to say if get one object in front, wall.class equals null, move 5. That's it. And I'm going to put that before each other object, each other move command down below. So now it's before all 4 of my move commands. So what's going to happen when I try and move, it's going to set my rotation no matter what, and then it's going to see if get one object in front wall.class equals null. It's going to see if there's an object in front of me, right? And by doing that, it's going to get my image. It's going to cut my image width in half to see how far to look. I'm going to get the rotation of my angle. I'm going to convert it to radians. I'm going to take the cosine and multiply it by the distance in front, round it up, and make it into an integer, and that's going to be my x offset, and do all the same thing except with the sine for my y offset, and then it's going to return the object in front of me, and if it's going to see if that thing is null, that is, if there's nothing there, I'll go ahead and move, otherwise I won't. And so I'm going to close here, I'll compile, and we'll see how it works when I run it. And you notice my walls are stopping me, can't get through the walls. But I can get the cheese as before. And now we have a better way to get an object in front of me. And next lesson, we're going to put in a cat that's going to try and eat us. See you then.